Okay, so here we now have our position time graph. So you can always plot the position of a particle as a function of time. Note here that this is not the trajectory of the particle, but rather it's only a graphical representation of the position relative to the origin of a particle. Usually displacement nga yan, pero sige. So yan, I've built animation. So you have your axis here, position as a function of time, and then you have a curve here. That's the curve of the position of a particle through time. So let's say initially it has some point x1 t1 or t1 x1. So it means that at time t1, the position of the particle is at x1, and then at another point, you have a particle at another point at time t2, you get something like an x2. Okay, and then let's let x1 be the position at time 1, let x2 be the position at time 2. Then, again, as I said, hindi to trajectory. The trajectory is what you observe. So, kapag nakita ka ng kotse na ganyan, gumagalaw ganyan lang siya. Ganyan lang yung trajectory niya. Pero dito, ang pinaplot natin ay yung position niya relative to an origin as a function of time. Hindi yung tina-trace na path ng particle. We will see that more on that idea when we go to 2D and 3D motion. Baka kasi nalilito kayo. Pero this is only a representation of the amount of the distance, the position traveled by the particle as a function of time. It doesn't give you the trajectory or the shape of how the object travels or how the particle travels. So yon. So we can create a line joining this initial point and the final point, and the slope of that line is the average velocity. So the average velocity is the slope of the line connecting x1 and x2. So we have average velocity here equals x2 minus x1 over t2 minus t1, which is your delta x, delta t. Okay? Questions? Questions? Again, the average velocity is the slope of the line joining these two. So slope of the secant line siya. Okay, may tanong dito. May tanong dito? Questions? Wala? Wala naman?
Wala po,
Okay.
sir.
Wala. Okay. Now, however, what we can do here is this. So, let's say for instance, we want to determine, halimbawa nasa kotse ka, and syempre, ang kotse may speedometer yan. Matakot ka pag walang speedometer yan. Ang kotse, at an instant, nag-register ng reading. Diba? Nag-register siya ng measurement ng speed, or in that case, velocity. The question is, how can the speedometer detect the speed at a certain instant? So what we can do here is from the previous slide, what we can do here is to approach this point x1 here towards this point x2 here. So ang gagawin mo, palalapitin mo ngayon yan dito. If you want to determine the speed at point x2, if you want to determine the velocity at point x2, what you want to do is to determine the slope of the line that's tangent at this point. Uy, slope of the tangent line, parang naalala ko yan. Siyempre, yung naisipin nyo. Parang naalala ko yan sa Math 21 or sa senior high school calculus ko. Diba? In that case, when we have that, what will happen is when you approach this point towards that point, the secant line becomes a tangent line now. And the tangent line, the slope of this tangent line is the velocity of the particle at that given instant. And that point is known as your instantaneous velocity. It's the limit as the change in time goes to 0 of the displacement per time. That's your instantaneous velocity. That's one that's measured by your velocimeter in that case. So, questions? So, may tanong ba rito? May tanong? May tanong ba rito? Wala?
Wala po, sir.